Hi everyone, today we are going to be starting what we call angle pair relationships. We're going to be doing this all week and we're going to be getting a whole bunch of new vocab. So bear with me, we're going to try to break this up into chunks so that it's not overwhelming to you, and hopefully you'll master all of these pairs as we move through the week. You will be seeing a diagram over and over again that looks very similar to a does not equal sign. In this diagram, we have two lines that are parallel to one another, and we have a third line that intersects both of these lines. And we're going to find out later that this line is what we call a transversal. Well, within this diagram, we get four different angles here, and we get four different angles here. And all of those different angles are going to create some patterns and some things that we need to be aware of, mainly because we're going to start to see these things later on in geometry a whole bunch. So for today, we are going to start with two different angles. The first is what we call adjacent angles, and the second is what we call vertical angles. So a couple definitions for you. Adjacent angles, we are going to call these two angles that share a common vertex and a common side. Now here's the thing, I'm like most of you are probably like, and that's I don't want to know what all these words are. I would much rather just see a diagram. And so we're going to include a couple of diagrams to help us sort of picture what's going on here. Okay, so two angles that share a common vertex and a common side. So I'm going to make this my common side, and then that makes this my common vertex by default. Well, then I just draw in two different angles. And so as we can see, this fits that definition. I have one angle here, I have another angle here. They both share this side and they both have their vertex here. Okay, adjacent means next to, so you kind of want to think about it as two angles that are next to each other. They're shoulder buddies with one another. The other angle we're going to talk about today is vertical angles. This we're going to call two angles formed by intersecting just means crossing lines. So two angles formed by intersecting or crossing lines that are not adjacent. So in this scenario, we're going to start our setup with two intersecting lines. Boom, done. Now, vertical angles are going to be any angles that are not adjacent to one another. They do not share a common side. So if I highlight this pink angle here, the vertical angle to that is going to be directly across this angle over here. Okay? And I also have a second set of vertical angles. This angle here with the bottom angle here. Okay, so you gotta want to think about them as they are diagonal from one another. All right, now that we've gone over a couple of definitions, let's practice. So looking at these four diagrams, I want you to pause this video, see if you can identify if the following examples show adjacent angles, vertical angles, or no angle relationship. It fits neither of those definitions. All right, hopefully you paused the video and we can check our work. So I'm going to start with the top left. First thing I notice is two angles. They both share this side. They both share this vertex. They are in fact right next to each other. They are adjacent angles. And I'm going to jump down here now. Again, I have a common side here. I have two angles that have this same vertex. That is what I would call adjacent angles. Once again, angle A is right next to angle B, so we call those adjacent. Moving over here, I'm just going to keep going counterclockwise. I see two intersecting lines there and there. However, angle A and angle B both share this common side. They are not across from each other. So just because I have those intersecting lines does not mean that these two angles are vertical. This is yet another example of adjacent angles. Last but not least, up here, this one, there's a little bit more going on because I have this extra line drawn in here. However, try to imagine that line not being there. Instead, we're going to focus on this line right here and this line right here. Now that I have these two lines highlighted, we can see I have two intersecting lines, angle A and angle B are directly across from each other. This is an example of vertical angles. And we tend to not see this as much. However, you do need to be aware that we can see vertical angles with extra lines thrown in. So you need to sort of eliminate the unnecessary information. Okay, now that we can hopefully identify them, let's throw a couple more definitions at you, and then let's actually start throwing some numbers in here. Okay, parallel lines, we should know that these are two lines that will never intersect. Two lines that will never intersect, two lines that will never cross, two lines that have the same slope. So you need to know that if they never intersect, they have the same slope. However, we're really going to focus on this not intersecting part in terms of our geometry work. Transversal, I dropped this term for you in the introduction to this video. This is a line that intersects two other lines. So if we go back to this diagram I gave you here, as I pointed out, my orange tick marks denote that these two lines are parallel, and then my pink line is intersecting those two lines. So this right here is a transversal. All right, so let's move back over here. And now that we've defined those, there's a fact that we need to know about vertical angles. This is really, really, really important. So all vertical angles, this is true for every set of vertical angles that you will ever encounter in math class, are what we call congruent. If we haven't seen this symbol right here, that's how we shorthand congruent. You will see it in geometry. And if you haven't heard of the word congruent before, all that means is they are the same. They are equal, okay? All three of those terms mean more or less the same thing. So let's practice applying that knowledge. Measure of angle G. So I'm looking at angle G down here. Is blank. Well, first thing that catches my eye is I have a 128 degree angle over here. The second thing that catches my eye is angle G and 128 are across from each other. They are vertical angles. What did we just learn with vertical angles? Is that all vertical angles are congruent. So because we know all vertical angles are congruent, they are the same. If I see that this angle is 128, I know this angle must be 128 degrees as well. I know this because it is congruent or vertical to the angle marked 128. So we can write in vertical or we can write in congruent there. All right, same sort of example here, but I would like you to pause the video, see what you can do with measure of angle A and the measure of angle D, and then resume this video and see if you got it right. All right, so I know that the measure of angle A is 52 degrees. What is the measure of angle D? Well, once again, A and D are directly across from each other. Since they are directly across from each other, they are vertical angles. Since they are vertical angles, I know that they must be congruent to one another. So if A is 52, then D has to be 52 degrees. Easy enough, right? Well, just like every single math experience you've ever had, as soon as something is too easy, we have to throw some more stuff into it, make it a little bit harder for you, right? So looking at these next examples, here's the deal. It's the same exact thing we've been doing before. Only difference is I have 2 to 3 extra steps with these problems. However, if you know your definitions and you know how to take those definitions and write an equation, you're going to be able to do any of these problems that I give you. So let's start. If the measure of angle 1 is 30 degrees, and the measure of angle 6 is 4x plus 2. Then find x. Well, what the heck, Miss K? What am I supposed to do with this? Well, it's a good thing that we learned all of our vocab, because right off the bat, I can see that I have an example of vertical angles. We just learned that vertical angles must be equal. So I know that the measure of angle 1 has to equal the measure of angle 6. Now, taking what I know here and plugging in things that are more useful to me is going to give me the equation that I am going to use to solve for x. I know that 30 has to equal 4x plus 2 because these two angles are vertical. They are congruent every single time. Once I'm here, I go through and I just undo everything being done to x. So we start by subtracting 2 from both sides. 28 equals 4x. How do I undo times 4? I divide by 4. So x equals 7. Go ahead and pause the video. See if you can do the last example and then resume and check your work. All right, we should have paused the video. Let's go ahead and finish this out. So they tell us measure of angle 8 is 75. Measure of angle 10 is 5x minus 20. What is the value of x? Okay, easy peasy, right? I see that these two angles are vertical. They are across from each other. So I know that angle 8 has to be equal to angle 10. What's more useful to me than using the measure of angle 8? Well, it's using 75. And I like this piece of information over here. Ooh, not 30. My bad. 20. All right, so I know that 75 has to equal 5x minus 20. Now it goes back to being a basic solve for x problem. I add 20. I add 20. I know that 95 has to equal 5x. I divide my 5 on both sides, so x equals 19. All right. Let me know if you have any questions. Hopefully this is pretty straightforward for us today. Tomorrow we're going to see a couple more terms, but this is pretty much all your notes for the day. Let me know if you have any questions. I hope you guys are all doing well, and this wasn't too stressful for you today. All right, have a good one.